processes, that log information, that process information, how can we pull that in and make it maybe a little bit more usable or useful? So great to have you here. It's a pleasure, my pleasure to be here with you. So let's go ahead and look at getting rolling. As Moria said, that Q&A box is, oh, thanks, David. Great. From the PowerShell. Glad to have you back. As Moria said, the Q&A box is, or chat feature is a great opportunity for you to feel free to, ask questions, reach out if you have a particular question about a topic that we're covering or a particular command that we're looking at. Definitely want to, as Maria said, make this as interactive as we can. So let's go ahead without further ado. Just a little bit about what the reactors are. If this is your first one, great. This may not be your first one, and that's great too. The reactors, really what it is it's an opportunity for us as community members to come together, right, and to learn from one another. This technology journey that we're on, it moves quickly. Technology changes fast, right? There's a lot going on, and trying to sort of stay ahead of the curve can be a little tough. So things like the reactors and these meetups and these opportunities for us as community members to get together can be a great way to help us all sort of continue on that journey. As far as a locality, one of the other great things about reactors is that there are options available all across the globe. I do hope there's a time when we can actually be in person again with one another, but until such time as that's possible, the fact that we have a lot of these remote and virtual sessions available across the globe is an excellent opportunity, and kudos to you for taking advantage of it. Just a brief little bit about code of conduct. As community members, right, we are a community together. So let's really treat one another with, let's see, Luna says she gets no sound. Is everyone else able to hear? Let's see. Okay, I'm not sure, Luna. Maybe try exiting out and coming back in. That might help. Thanks for confirming, folks. From a code of conduct perspective, we are a community, so let's treat one another with respect and kindness, right? Let's be aware of one another, be friendly and patient, welcoming and respectful, open to all questions and viewpoints. This is a learning environment, right? And so with learning, there are going to be questions. That's how I learn. Different people learn in different ways. I learn by asking questions and sort of inquiring about things that I don't fully understand to get a better understanding of it. So let's be open to those questions, be understanding of differences, and once again, just be kind and considerate. So this is going to be a great session. We are a community. Let's approach this and kind of proceed as a community. So, all right, let's go ahead and get right into the sort of meat of what we're going to be talking about. So, as I mentioned, maybe you are a longtime Unix or Linux user, right? But maybe you haven't had a chance to maybe get exposure to some of these commands that we might leverage or utilize to kind of comb through log data that's available to us, right? Maybe you're brand new to Linux or Unix, right? Maybe you've not done anything on those platforms yet. So this might be a good chance for you. Oh, great, Luna. Okay. Yeah, good. Maybe this is your first sort of foray into Unix or Linux, or maybe you've just started, right? So great to have you here too. In that respect, we're gonna, kind of talk about a few commands that we might consider common, or maybe, or that some of them more common than others. But really, what we're trying to do is build a foundation for how can we leverage this tool set to get information, right? Because when we are, running applications within Unix or Linux, we're trying to support a particular application, or maybe, as I said, we're building something out and we need to do some troubleshooting. There is can be a lot of information available to us, right? Applications are very good about logging things that happen along the way. The problem is that information can be massive, right? And so sort of trying to figure out how to dial in and, focus on the specific piece of detail or data that we need to really, help us can be a little bit challenging. One option is to sort of open a file, start at the top and read our way through, which is, gosh, that would be rough, right? But another way is to kind of leverage some of these tools. And that's what we're really going to be trying to talk our way through. This will be kind of a combination informational, where I'll go through some information on slides, and then we'll be able to walk together through a Cloud Shell in browser and try some of this out. So great. Maria mentioned a little bit about me. I've been doing this for a while. The one thing so I've been 25 plus years, architecture, design, development, several large verticals, some smaller consulting gigs as well. I've done a lot of teaching. The one thing, though, I really want you to know about me is that I'm passionate about learning. I'm passionate about my own learning. I'm passionate about others' learning. So that's why it's really cool for me to be here with you folks today. So here's our agenda, right? We're going to talk introduction, file inspect, and then we're going to start to dig into, okay, so how do we first inspect the raw data we have available to us, right? Because if we're trying to figure out or get answers from information, sometimes that initial inspection can help us sort of chart our course, right? Figure out which direction we should take. So we're going to talk file inspection. We're going to talk basic file manipulation. We're going to talk about regular expressions, which I think are a very, very cool feature. They can be a little cryptic. It can take a little bit of getting used to. We're going to sort of begin, and I think the cool thing is the regular expression discussion we're going to have today should apply in multiple spots, right? Not just to what we're doing here, but if you program in other languages or need to support other systems, I think you'll find regular expressions can be fairly pervasive and would be a good skill to continue to build. We specifically are going to use grep with regular expressions to do some searching within file contents. We're going to look briefly at the stream editor, which allows us to do some substitution. And then we'll kind of wrap it up with pipes and filters. How do we put all of this together? And we'll see how pipes and filters allow us to sort of combine multiple commands in one line of code. Okay. So again, any questions, any comments, definitely feel free to leverage that chat box. Tail and head, always useful too. Great comment there, David. We are actually going to talk about tail and head in just a bit. So good call out. All right. So wrangling data, right? So sometimes, as I mentioned, that data requires transformation to make it more useful, right? We could have a ton of data coming at us, raw data, log data, stream data. Data, the more data, usually the better, right? Because that gives us a fuller picture. But trying to figure out how to consume that in an efficient manner can be a little tougher, right? So we're going to look at, as I said, multiple tools within Unix or Linux, however you want to, whatever you want to, whatever route you want to go in terms of terminology. We're going to look at tools within the shell that can help us wrangle that data. And that's what we mean by wrangling, right? Is just transforming, taking that information in its raw form and trying to move it into a format that is maybe a little bit more useful. We're going to start with just sort of the concept of terminal streams, which are very key in Unix, right? And there's three kind of main ones. There's the standard in, which is your input stream, usually attached to the keyboard. The standard out, which is your output stream, which can either print to the screen or can pass results on to something else. And then there's the standard error, which is primarily used for error reporting and often prints, information about problems that occurred to the terminal. So those key streams, we're going to see those concepts quite a bit in what we cover off on today. All right, so first thing I want to do is let me grab this link and post it in the chat. One of the cool things about these reactor sessions is that you actually can follow along with me, and I strongly encourage you to do so. Definitely feel free to follow along. There's, these, and let me just launch this and we can kind of see. Bring it over here to this screen. So this is the Microsoft Learn platform, which I think is terrific. The Microsoft Learn platform provides you with learning modules. Those modules have units. And what we can do within those modules, right, is we get a combination of context-specific, detail and links and documentation, coupled with exercises, hands-on, step by step. And depending on how you learn, right, different people learn in different ways. That can be a great tool, right? That combination of documentation and then the chance to sort of put it into practice immediately can be very, very helpful. So I really highly recommend the Learn platform. That's what we're going to be using today for our topic. So go ahead and get ready for moving into that. There's quite a bit of text within here, but we're not going to go line by line through the text, right? That's what the slides are for, is just to sort of sum that up. But we are going to have a chance to sort of dig into some practice here shortly. Okay, so let's talk briefly about file inspection. Okay, so before we wrangle, right, before we transform information into the format we need it to be in, a lot of times we need to understand the format that it's currently in, right? And so exploring those raw contents can be very, very helpful. David already mentioned two key sort of tools that we can use there, tail and head, which we're going to talk about in just a couple of minutes. There are multiple commands, though, that allow us to sort of inspect files, inspect streams. And the key is, there are commands and options that allow us to sort of, zero in, right? So instead of looking at the entire set of file contents, for example, we can look at the top number of lines in a file or the bottom number of lines in a file, which is head and tail, as David mentioned, right? These are commands that allow us to take a file that could be very, very many lines long, right? And just focus on the first X number of lines or the bottom X number of lines, right? By default, it's going to display 10, right? Will these slides be uploaded afterwards somewhere? Probably not. But you can go back, Luna, and review the YouTube recording so that you can kind of review the information that way as well. I should probably provide for that. So that good call out. Unfortunately, though, didn't prep for that ahead of time. Okay, so we can use head and tail. It's going to give us 10 lines by default, but we can use a -n flag to sort of specify the number that we want. Now, why would we do this, right? Why do I care about the first few lines of a file or the bottom few lines of a file? Well, you may not, right? But if you imagine, say you're trying to understand the shape of your data in a particular log file, right? Rather than looking at the entire file, let me just look at the first 5 lines, right? If I look at just the first 5 lines, I can quickly see what a given line of data looks like, right? I can get a feel for the shape of the information. If you're actually looking at a log file that logs data by time, right? So the latest things to happen are at the bottom of the file. If you use tail, you can kind of find out what most recently occurred from an event perspective, right? So for that reason, head and tail, among others, right, can be beneficial. There is an NL filter, right, that allows us to basically number the lines within a text file. Why would you want to do that? Well, that can be helpful so you sort of are able to get a indexed reference point to a line within the file that might be problematic, right? That allows you to sort of index that information, count that information, and provide, a numeric index to go along with each line. When you run this command against a file, it's going to give you the number, the line number, and then it's going to give you the text. You can specify a particular delimiter that you want to, be between the index and the data, because what you could then do is translate that or transfer that information elsewhere, and then split on that specific delimiter, for example. And that -s flag allows you to do that. There are also ways through the -i flag to, kind of change the increment value. By default, it's going to increment by 1, but maybe we want to change that up. We can change the number format, right, using the -n flag. with either an LN, which means left justified, no leading zeros, RN, right justified, no leading zeros, or RZ, right justified, leading zeros. And we'll see an example of that briefly in just a minute. And then we can also change our starting number. It's by default going to start at 1, but we can change that if we want to. Okay, so we talked head tail, we talked NL filter, let's talk WC. That's another potentially beneficial command that allows us to get a count of the number of lines, words, and characters within a text file, which can be very useful, right? Maybe you care about the file that has the most information in it because that's where you want to start your analysis, right? Or maybe you care about the file that has the least information in it because maybe you expected there to be more and there's not, right? So we're going to see that we can use the WC command to assess kind of the contents of a file and then pipe that to other commands to sort of find, you know, the first one, the one that has the least number or the most. Okay. So let's flip over here back to our Microsoft, and let me just bump this up a little bit so it's easier to see. So I'm going to start here at the introduction module. I just gave one of these talks last night, so I've already visited a lot of these. So I'm going to start back from the beginning. Let's go to the file inspection. Okay. So there's a lot of text here that basically defines, you know, what we just covered on those slides. So I'm not going to go through the text, but I am going to go through the commands here. One of the very cool things about the Learn platform is the opportunity to leverage an in-browser sandbox. Excuse me. So maybe you don't have a Unix or Linux installation, right? Maybe you don't have a Unix or Linux machine available to you. You know, and so in a lot of these Learn modules, you'll see that there are tools provided for you to test out the information that's covered without necessarily having to have, you know, all of the software installed or the exact matching environment, which is kind of nice. If you are on Windows 10, you might find it useful to use like Windows Subsystem for Linux, which allows you to install, you know, a native kernel version of like Ubuntu within Windows 10. That's what I use. You might use Git Bash as well if you're on Windows, the Windows platform. With Mac OS, you'll have a terminal, which is more, you know, ZSH. But for the purposes of what we're going to be covering off on today, we can use the sandbox, right, to kind of test. So if you click this activate sandbox, it may ask you to log in. And what it's basically doing now is it's building out a set of sort of temporary resources within Azure that I can utilize for this, you know, for this subject as we're talking through. Now, you get 10 sandboxes a day, and usually a sandbox is around for about 4 hours, which I've found to be plenty. But it's going to go ahead and do the rest of its sort of setup and configuration here. Takes just a bit. And again, what this is doing is setting, you're not getting charged anything, right? It's not charging you anything. It's setting up temporary time-bound resources in the cloud for us to utilize for our testing. So I'm going to use clear here, and I'm going to list the contents of the current directory, which there's only one folder called Cloud Drive. What I'm going to do is make a new one. The way you make a folder in Linux or Unix is make dir. And so now when I do an ls, I see that I have a data directory or folder as well. Now, in order to sort of test some of these, we're going to pull down some test data, and we're going to use NASA information, which I think is kind of cool. Some NASA logs and some information from the NASA software API. It's a little dated, but that's okay. We're going to pull that information into our Cloud Shell. The way we can do that is with this wget command. This wget command allows us to pull a text file from, for example, a GitHub repo or location and post it to a folder of our choosing. So we're gonna, first of all, grab this one. Let me copy that. And then over here, I'm gonna paste it. That's gonna pull down the first file we are interested in. And then I'm going to grab the second one. All right, so let me clear my screen to get rid of that extra text. If I change now to my data directory and do a list contents, I see those two files, right? I have those two text files that got pulled down into my, into my Cloud Shell. All right. So let's first of all look at head and tail, right? So as I said, could be that this information is a log file over time, right? Might give us a log of information as things occur in real time. And maybe I care about the last 5 things because I want to know what's the last 5 things that happened. What are the last 5 events that took place, right? So tail is great for that. Now, if I just do tail against the NASA software, I'm going to get, you'll see here, 10 lines. These are the last 10 lines of that text file, because 10 is the default, right? If I do a tail, tail with the -n flag, then I only get 5, right? I get these last 5. You'll see here, open source, 06, 09 here, and it goes up from there, right? So that's a way with tail that we can sort of specify just the specific number that we want, which is, provides the data at the bottom of the file. Now, each one of these commands is interesting, right? But where we're really going to see the power come in is when we start to pipe them together and wire them together using pipes and filters. But to get there, we need to sort of build this foundation first. So the other one, obviously, we can do head. That's going to give us the first 10 lines. If we do the -n here, we'll only get the first 5, right? So that's head and tail. Gives us the ability to get the first lines or the last lines in a text file. Okay, any questions, any comments, definitely please feel free to leverage that chat window. All right, so let's look at NL now. If I do NL against the NASA software, you'll see here that each of the lines are presented here, and it's added this index, this line number, right? Which is useful to sort of see how many are there. If I care about a specific line number, I have a way to index it. Right now, by default, it just uses a tab separator. But if I use the -s flag, I can, give it a different delimiter that I'd like it to use. So now you see the line numbers with the equal sign. As I said, there are other options here as well. Let's do a -n, and let's do right justified with zero padded. Should we see a screen share rather than a camera? You should. Is anyone else not seeing the screen share? Are others able to see me typing within the browser? Yes, I just see you. Okay, I am going to actually turn off my camera and see if that doesn't help. Do you see the screen now? You can see both. Oh, maybe double clicked on me. Okay. All right. So what I did here is I used and within a terminal, right? If you use the up arrow key, you can actually revisit commands that you've executed previously. So this command that I executed, the -nrz, gave me the line numbers, but they're good. Paul, thanks for confirming. Gave me the line numbers, but I have the index, and now they are right justified with 0 padding. Okay, so that's just, again, depending on the format that you want. If you want to get a consistent format in terms of the numbering, that can be useful if you're doing some processing by position. All right. Okay, now let's take a quick look at WC. So here we see that there are 703 lines, 8,917 words, and 81,115 characters within this file. So, that with this WC gives you a quick view, and there are flags that you can use, which we'll look at shortly, that allow you to focus on just one specific piece of that information. But that gives you some sort of statistics or metadata about the file, right? Now, the interesting thing here is that WC says there are 703 lines. But if I go back to NL, let me just go back to that command. There's only 700 lines. What's going on? Well, the issue is that NL by default doesn't include blank lines. WC will, right? WC is going to say if it's a blank line, it's a line. So I'm going to count it. NL by default says, no, I don't count those. But there is a way to, sort of using the -B flag, we can say, I actually want you to include everything. And now we get the same count. 703 lines with WC, 703 lines with NL. And again, these commands on their own may not be super interesting. I understand. What we're going to look at, though, is as we build this foundation, how do we go from here to combining them to do more interesting things? So stick with me. We'll continue as we go. So that's head, tail, NL, and WC. Let's now go back and look at some file manipulation. So that was file inspection. Well, one of the tools that we can use for file manipulation is the cat command, which is a very, very common command. And the cool thing about cat is that it actually provides 3 functions. Cat gives you the ability to, display the contents of a file. It actually allows you to create a file in like an interactive edit mode. And then it allows you to sort of combine 2 files and then either output the combination to the screen, or we can save it to another file. So let's look at these 3 sort of functions. Displaying the file contents is pretty straightforward. It's just cat and then the name of the file or the file path. The default output destination is going to be standard out, but we can pipe that to something else. Okay. So if I just want to see what's in the file, I can use cat without any sort of arguments. If I want to create a new file using cat, I can use cat with the greater than sign and give it a file name. That will enter an interactive edit mode that I can start typing information in. And then when I hit Control D, that sort of exits edit mode and saves the information I've typed into the file name that I provided here. Now the single greater than sign is going to overwrite the file. I could also use a double greater than sign to append. So if I wanted to add information to the end of an existing file, I can use 2 greater than signs. And then combining files, we can say cat with 2 file names. That will output the combined contents to standard out. If I use my greater than or single or double, I can actually redirect the combination of those 2 files to a third file, right? So I can basically create a new file from the 2 files combined. So let's take a quick look at what that looks like. Let me clear this out. And again, any questions, any comments, definitely feel free to ask away. Always welcome that. Okay, so sort of briefly here, we're going to look at, first of all, the first function, right, where we just say cat against the file name. And that's going to just list all the contents. Now, you know, this is a pretty large file, so we have to sort of scroll through the screen. One helpful thing you can do with cat is you can, and let me just go back. If I pipe that using the pipe command, or pipe key rather, which is right above the, should be right above the enter key with the shift. If I do that with more, then I can actually navigate the file line by line, which can be, you know, useful. When I'm finished viewing the contents within this sort of line by line mode, I just hit Q to exit. Okay. For that, let's look at creating a file using cat. All right. So if I do cat greater than file1, you see now I've entered this sort of interactive mode. So if I type NASA headquarters, hit enter, and then if I do Control D, I exit edit mode. If I list the contents of this folder, now you see file1. If I display the contents of file1, you see that it's the text that I entered, right? So that's another use for cat. If I wanted to, I could use with 2 greater than signs, and now I can add some, or append rather, additional text to the end of that file. Again, Control D to exit. And if I look at the contents of file1, now I've got the 2 lines of text that I entered, right? The first one was creation, you know, overwrite the contents. The second one was append. Any questions, comments? Okay, great. Now let's look at, you know, concatenating 2 files. So if I do a cat file1 and file1, maybe not super interesting, right? But hopefully you can imagine the uses that you might have for this, right? If you have 2 different files, text files from 2 different machines, for example, and you want to get a full picture of all of the machines that you're supporting, cat can allow you to do that, right? So here I have combined the contents of this file basically twice, but it's only gone to the screen, right? If I look, file1 is still just those 2 lines of text. This concatenation went to the screen only. If I wanted it to go to a file, I could do use the greater than sign for file2. Now you see file2 that has the combined contents. And then finally, what I could do is actually use 2 greater than signs to append. Okay. So cat is definitely a command that you're going to want to get you know, some familiarity with and find an opportunity to leverage, I'm sure, within your Unix data wrangling, certainly. Okay. So we talked about file inspection, basic file manipulation. Let's look now at regular expressions, which are going to be, I think, again, a great thing to sort of get a handle on if you've not seen them before, because they have applicability in multiple places, not just within the Unix shell. So what are regular expressions? Well, regular expressions, it's basically a syntax, right? It's a proprietary syntax that provides compact definition for pretty sophisticated pattern matching. So regular expressions can be used for things like if you are expecting the user to have input an email address. That email address has a particular pattern or format you'd expect, right? Some text, an @ sign, and then some text with a .com or a something else, right? So that pattern, if we had to try to sort of evaluate the entry from a user and look at it character by character and say, okay, is this, you know, if you imagine trying to build code to sort of interpolate that email input and make sure it's valid, you could do it, right? But with a regular expression with 1 line of code, you can verify that it matches a format you'd expect. Same thing if you had like a phone number, right? If you had an IP address, IPv4 address, for example. So there are all of these sort of ways that you can use regular expressions, and they just give you a compact syntax for pattern matching, right? And the pattern matching, as I said, can be fairly complex. Now, it's a little cryptic. I will give you that. If you've ever seen regular expressions, they can be a little hard to read. But as you get used to them, I think you'll find that they are a very powerful tool. And you're going to find them in most text editors. You're going to find them in most common or current languages. This is, I think, a cool resource that you'll probably want to revisit if you're new to regular expressions. And even if you're not, I find this useful just to go back, even though I've used them for a while. This RegEx 101, if you navigate there, you'll see that it allows you to sort of specify a regular expression. And we're going to see here shortly that a regular expression really includes three things, right? It's the regular expression, which is the pattern we are trying to match against. It's the input string, which we're actually testing. And then there's some sort of match result, which is a Boolean, true or false. Either the text matches the pattern or it doesn't, okay? And so if I put in here ABC 1, 2, 3, then down here ABC 1, 2, 3, you see it highlights to show that there was a match. That's the other cool thing about RegEx 101 is it gives you sort of an explanation of how it matched. Now, if I did ZABC 1, 2, 3 with a 4th, and it's still going to match that, right? We're going to talk about some anchors that we can use that basically ensures that we're searching against the front of the string or the back of the string. But with regular expressions, you can just do something like this, right? You can just search for a string. Where it really becomes interesting is if you do something like that. What does that mean? Well, 1, 2, 3, 4, 5. It's going to be 5 digits, right? Matches 5 digits, right? Equivalent to 0 through 9, which we're going to look at shortly. It matches the previous token exactly 5 times. And if I wanted -3, now you see it matches as well. So hopefully you're getting a sense that, with these regular expressions, you can, and this is fairly straightforward. Let me see if I can find a regular expression. Here's an example here, right? Which can be a little bit more complex, right? But, those types of things. So if I do A Sanders at MSN, nothing, com, and it doesn't. Oh, it's not matching. I'm not sure why. I found a bum one. Here we go. Hold on. You get the idea. If you search for regular expression for email address, you can find one available. I don't have it off the top of my head. As you can imagine, it can be a little bit cryptic, right? Looking through this can be a little bit tough to kind of read. Here you have the ability to say it's between 2 and 4. All of these different sort of cases that can make for a pretty hard to read sort of evaluation, but a very powerful tool that you can use for pattern matching. Yeah, maybe it is the end of line there. Maybe it's I'm not sure. Not important right now. You can find a regular expression for email. There are regular expressions for, as I said, phone numbers, IPv4, IPv6 addresses, and many, many other things. There are regular expressions for phone numbers that are in, the US format, and for regular expressions for phone numbers that are in the European format. Any number of those you can find. But that RegEx 101 can be a really helpful tool. So definitely suggest that you kind of use that because I think you'll find it useful. We said, hey, the concept's a pattern, a string to check against the pattern, and then a flag that indicates whether or not we found a match. We can use it to search for full strings, which we saw with the APC-123. The real power, though, is in the pattern matching syntax. And let's look at some sort of quick samples here. We've got the square brackets can be used to specify a range of characters that we want to match against. For example, we can use square brackets A through Z. We can use square brackets 0 through 9. This would match against any letter. This would match against any number, any digit, right? It's a single occurrence of that match, right? So this would say one character that is within this range, one character that is within this range. Now you can also specify your own set of characters. Like if I just have, a random set, A, B, C, D, J, K, L, I want to match a specific character to that. I can do that with this square bracket operator within the regular expression. There is a dot that we can use as a wildcard. The period is going to match on any character, okay? And we can use it in an expression like this, fi.e. So if we go back over here to so file matches, find matches, 5 matches, right? Anything Dave is not going to match, right? Because the first 2 letters need to be FI, the last needs to be E, but this third character can be anything. Okay. We can also use the dot with the asterisk to match any character 0 or more times. That asterisk can be applied in multiple spots as well, right? But the dot asterisk allows us to sort of give, if we want to say it starts with this, but we don't care about the rest of the characters after what we're concerned with or interested in, we can use the dot asterisk to help with that. Anchors, right, allow you to either search to match at the start of a file with the caret, or search for a match at the end of the file, or the end of the line rather, with $sign. And then if we want to match a literal occurrence of the period, right, we don't want to use it as a wildcard matching any character. We're interested in specifically matching a period within our text. And we can do this with pretty much any sort of character. We can escape it using the backslash. That will tell the regular expression, don't see this as a special character. See this as its literal, the literal character. That's what I want you to look for in the pattern. Here is a cheat sheet that is within that Microsoft Learn, set of modules that you might find useful. Also, if you click, and let me provide this as well. There's some good Microsoft documentation around regular expressions here as well that give you additional sort of information, right? So ranges, anchor. We've got things like the square brackets, which allows you to specify a number of occurrences. The \D, which allows you to match a digit, right? A numeric digit. So take a look at this information. Hopefully you'll find that, I think, useful as well. Okay. Let's do back over here in our, let's go and just try a couple of quick exercises here. Okay. Let me clear this. So one of the cool things about the Cloud Shell is you can actually go into sort of a code view as well. It's sort of integrated with Visual Studio Code. So if I do code against the software file, that's going to launch another window here, which is more interactive in terms of, this is like a code view, right? Here's our terminal still down here. here's the code view of that file. One of the things we can do within that code view is if I click here and then I launch search, which is Control F or Command F, depending on if you're on a Mac. What I can now do here is I can search for open source. And if I click this regular expression, you'll find that a lot of times these IDEs, these tools give you the ability to search by regular expression. So now it's not really going to look much different here, right? Because I'm just checking for a basic string. But if I wanted to look for arc dash 5 occurrences of a number dash 1 occurrence of a number, then I could find all of this, right? All of these matching strings using that regular expression. So kind of cool that, that regular expression, as I said, you're going to find that it has applicability far and above just what we're doing here in the Unix shell. Okay, so if you click these 3 dots up here, I can close that editor. We'll come back. Let's talk quickly about grep. Grep is a great tool for searching for text inside of a file, right? For searching a file's text. It can, search within a file. It can search against the standard in or the standard input stream as well. And you can use a regex pattern for that search. So you can hopefully see where you start to be able to combine these things to get maybe more powerful features and capabilities. The general usage is going to be grep with the pattern and then the file you want to search against. There are multiple flags that you can use to control the search, and it also provides the ability to search against multiple files. So let's look at a couple of those. Here are some sort of common things that we can do here. Like grep-c is going to count the number of lines that match a given pattern. And you'll see it's equivalent to this grep pattern against the file, and then piped to the wc command with the -l flag, which counts the number of lines. There you see the pipes, right? We take one command, and the output from that command gets redirected or piped into a new command, and the new command works against those results. You can see grep-i for case insensitive, grep-n for line number and match pattern, etc. Right? So these are some different flags that you can use with grep. Now let's take a quick look here within the shell here. So let me clear this. If we do a grep, I'm going to actually just copy this and then we'll talk about what it's doing here. Okay. If I hit enter, you'll see that it is going to match occurrences that include a literal asterisk, right? Not the 0 or many syntax that regular expressions typically see the asterisk as. With the backslash, it's going to look for a literal asterisk, a literal period, the text novo, another literal period, and the text TK. So it's going to show me from this file all of the lines that match that pattern. It's a way to search within the contents of a particular file. Now, we could also do, multiple searches. So I'm going to search against 2 files for the text NASA. And now you can see here that I've got quite a bit of information from the 2 different files, right? It combines all of that together in one result. Here's one format of the file, which is the API information. Here's the other software detail or log detail. Okay, any questions or comments? Hopefully making sense. And again, what we're doing is building that foundation of sort of individual commands that you can then take and, build out into, using pipes and filters, something that's a little bit more complex. All right, a couple of more areas to go through here. Let's talk about stream editor. So sed, or the stream editor, is great for text parsing and manipulation. It operates on a file or against the standard input stream, provides you read access to the contents of that file. But it also, and this is maybe where it's more powerful, gives you the ability to do text substitution, right? And that's where some of that transformation comes into place. Say you have two log files from two different machines. They have the same information, but their format is a little different, right? Maybe they use a column name that's a little bit different from the other machine. Using sed, for example, you can transform those to make them more, sort of normalized and easier to combine together and consume as a group. So that's just one case where you might be able to use sed. And a lot of times, we are looking at these commands within the terminal, how we might execute them in the terminal. A lot of times, these commands will be combined into full scripts, which are files that get saved. And they're basically programs that include a list of these commands. And then those scripts can be executed as needed or, on a scheduled basis to, automate multiple tasks in sequence. And so you might find sed in that context as well. Basic usage is sed options commands file name. We can use an empty set of commands against a file to just basically output its contents. And that's going to be similar to cat. So we looked at cat for reading a file's contents. Similarly, we can read a file's contents using sed with no options and no commands. If we want to actually search for a regular expression pattern and replace it, then we can use this S flag. And then we separate the old text, what we're searching for, from the new text that we want to replace it with using forward slashes. So that's very important. Those forward slashes are very important. And there needs to be a trailing one here because sed provides some capabilities to specify additional options at the tail end of this substitution argument. So by default, it's going to output everything. So when you run sed against a file, if it replaces anything, it will replace, but it's going to show you the entire file's contents. We can use the -n flag to suppress that automatic display. And then we can use a P flag to show only the lines where a replacement occurred. When we execute sed to do text substitution, it's only going to print that substitution to the screen. We can use the /W flag to actually write those replaced lines out to a new file. So let's take a look at this in our shell here. Let me clear our view on this side. So let's take a look, for example, at this first sed, no options, no commands, and just a file name. That's just going to give us the file's contents, right? It's going to look very similar to the execution of cat. Okay. Now, we can actually, if you wanted to, I'm not sure why you would do this, but you could pipe results of cat. You could pipe those to sed with no options and basically get the same, sort of effect. Now, probably where sed comes in most sort of the most interesting places is with the substitution. So let's look at that briefly. We can do substitution of text that's just in line, right? So if I do echo, actually, I'm just going to copy this and then we'll talk about what it's doing. Here, I'm going to simply echo. If I just let me get rid of this part. If I just echo this, all that's going to do is output that string to the screen, to the terminal, right? If I go back to originally, What I can do is I can actually echo, let me see if I can echo that string and then pipe the results to the sed command, which allows me to look for index.html and replace it with home. You'll notice the forward slashes, those are very important. When I run this, what we get is the same string, but instead of index.html, it's been replaced with home at the end. Okay, so that's sort of a brief a brief example of sed's use. Let's look at operating against a file. So if I clear this, if I do a replacement of the characters NASA with National Aerospace Agency, all right, I can run that against the NASA software file, and it's going to output all the lines. Now, I don't know which one of these lines got changed. You see, it looks like one here might have gotten changed, right? Because maybe it said NASA before, but it's given me the entire file contents. If I specify the -n flag, which that's going to suppress the automatic display, and then specify a P at the end here, it's only going to show me the lines that got changed, right? A much smaller set of information. Now, this is all just going to the standard out, though. It's all just going to display on the terminal. If I wanted to actually write this to a file, I could run this command, but instead of P, I can do W and then give it a new file name. When I list, I now have this NASA-replaced. If I look at that file, you'll see it's just the lines that got changed, right? Just the lines that had a substitution executed against them. Okay. All right. Hopefully that's making sense. I know we're moving a little quick, but we're just about out of time. Let's put it all together with pipes and filters. So the way I think of pipes and filters is, and we talked about this same sort of analogy with PowerShell, if you were with me last week. Pipes and filters are kind of like, think of a set of train cars. You're going to have some kind of input potentially to the first car. There might be some level of processing that happens, and that first car is going to give you some output. The output from that first car is then going to flow into the second one, which might do some additional processing, right? It's sequenced, right, from start to finish. And what it allows us to do is combine multiple commands into one single line of code, right? We can redirect stuff to another file. We can redirect stuff to another command. And it basically allows us to construct a sequence of commands that can be, pretty powerful. Now, here's a couple of links with some additional information on filters and pipes. Let me just post that here for the heck of it. They really, what the pipes and filters allow us to do is more with less code. They can be a little hard to read, like the regular expressions, but you're going to see them very often if you look at any amount of shell code for any amount of time. You're likely going to see them, and they're very efficient, right? So definitely something to sort of begin to get your head wrapped around. If this is all new, no problem. Take this as an opportunity to build that foundation and then build on top of it. So let's look at a couple of examples here. Okay, so I'm going to clear. We've seen this pipe. So the pipe is basically the mechanism that does the redirection. The filter is what the redirection goes to, right? It's what you get redirected to. So if we do this, we can read the file's contents and then pipe it to NL, right? Now, we don't see the results of, we don't see the results of the cat statement, right? Those results are piped into NL. We see the results of the combined statement, right? We can look at the number of lines within all text files in this folder. That shows us the the files and the number of lines. Also sort this so that it is in, from ascending order, right? So it sorts in ascending order. We could also reverse that to show that information in descending order. So just a way for us to sort of, again, begin to combine these things to manipulate or to do more sophisticated manipulation. If we do this, we can actually sort it and grab the first one. That's going to give us just the one with the least number. If we wanted one with the most, we could do that, right? Which that's given us basically the data here. All right, let's look. Here's an interesting one. NL software. Let's pipe that to head, and then let's sort that in reverse order. What this is doing is giving me line numbers across the entire file. The output from that then goes to head, so it only gives me the first 5. And then those first 5 lines get sorted in reverse order. So we see 5, 4, 3, 2, 1. Now, the important thing to recognize with piping and filtering is that order matters. The sequence matters, right? If I had put the sort before the head, I might get a different result, right? I would get the bottom 5 lines of the entire file. So it's going to happen left to right in sequence. That's key to sort of remember. And then last one that we want to look at here, and then we'll call it a day. I'm just going to copy this instead of typing it and then tell you what's going on here. This is going to find the first 10 occurrences of the NASA characters in this file. It's going to sort those 10 occurrences in reverse order. And then it's going to replace within that set of lines NASA with National Aerospace Agency. So what we should end up here with is 10 lines, right? Sorted in reverse order. And then instead of NASA, we see National Aerospace Agency replaced. Okay, so, take an opportunity to continue to practice with these commands, continue to study. Let's look at sort of closing out. We didn't really have time for the knowledge check, but you can go back and do that yourself. What did we cover? We covered data wrangling, file inspection, and basic file manipulation, regular expressions and their use with grep, text manipulation using sed or the stream editor, and then putting it all together using pipes and filters. Take a look at those links that I provided and maybe walk back through the same information again. Let me just repost them. Walk back through that information again for some further study. And, again, use this as an opportunity to build a foundation that you can then build upon. That's the last thing I had. If there are any questions, please feel free to post them in the chat. And then alternatively, or additionally, I should say, if you could please, thanks, David, if you could please fill out this survey using 13069 as the event code, that would be awesome. This is your opportunity as a community member to tell us what is most beneficial to you in these sessions so that we can try to, kind of fashion these in a manner that are as useful as possible. So if you could fill out that survey with 13069 as the event code, that's great. Any questions at all? All right. Well, I just want to let you, let's see. Yeah, thank you, Moria, for sharing that survey. Just want you to know that for me, this was a true pleasure. I hope you enjoyed it. I hope you got something out that you can build upon. Great being with you today, and I wish you nothing but the best going forward. See you next time.